due to the only difference between these two groups is that this group is getting the smoking, and this group isn't. So, like we said, this really doesn't make sense for smoking. However, it does make sense for other studies. For example, suppose we want to know if a newly developed medication can reduce symptoms for COVID-19. So what we would do is we would gather a group of people, I guess people who are have COVID-19, and we would randomly assign them to the control group and the treatment group. Now, there's a slight bit of an ethical problem here, you can see, because who gets to go into this group? We have this new medicine. We would think everybody wants to go in here, but we really don't know what is going to happen as a result of this medicine. We're testing it, and it could have negative effects as well as positive effects. So anyway, it seems like there might be an ethical problem, but there's no real solution to that. So we're going to put people in here and people in here. And then if the people in here improve, we can say that it wasn't because of other variables, other confounding variables. It was because of this new medication. Now, there's one other point that they usually make in this kind of discussion, and they say, okay, we're going to give these people the medication, and these people are not going to get it. But actually, we give them basically just a pill that has no effect, like maybe it's just a sugar pill or something that has nothing of no active ingredient in it. And the reason for that is that there have been many studies that show that when people think they're getting medicine, they actually improve. And for example, there have been studies that show that when people are in a hospital and they're told they're being given pain medication, even though actually they're not what they're given has nothing to do with pain, they report that the 30% of them report that their pain symptoms have gone down or subsided. So we want to avoid that. We don't want people to get better because they think they're getting the medicine even though they're not getting anything, because that doesn't tell us about the true effect of the medicine. So that is called the placebo effect when that happens, when people report that they're feeling less pain even though they didn't receive any real treatment. So we give what's called a placebo to the control group. So for example, like I said, we'll give them a sugar pill. So the sugar pill is called the placebo. So suppose we have 250 patients. We divide them into two groups, the control group and the treatment group, and we give one group the new medication, that's called the treatment group, and we give the second group the sugar pills. The sugar pills are called the placebo. And the point of this, again, is that we have eliminated all the confounding variables by doing this. And so if there is an improvement in the treatment group, we can ascribe it to the effects of the treatment, of the new treatment, the new medication. Okay, so going back to the observational study, in an observational study, we're not doing this kind of random assignment. And so we're never really sure about whether there's a causal relationship. So we might say that when smoking increases, that cancer also increases, but we can't say that the smoking is necessarily causing the cancer. It could be things that also increase with smoking. And so in an observational study, we're kind of stuck with that. Whereas if we can do a controlled experiment, now as we said, we can't do that with smoking, but if we can, then we're able to talk about one thing, this new treatment causing the effect. Okay, that's all.